Hey, I'm here in the Pacific Coliseum. This is the home of the Giants, but for 25 years this was the home of the Vancouver Canucks. They played here. I actually was lucky enough to come to the first Canucks game in 1970. I was 2 years old. They were playing the Los Angeles Kings right there. They lost, unfortunately. I was also lucky enough to come the first time they ever went to the Stanley Cup Finals, and they lost there again in Game 4. But I got to see the Stanley Cup get carried around, even though it was the other team. They've been to the Stanley Cup Finals 2 more times since then, once on that ice in 1994, and pretty recently against the Boston Bruins. We're gonna look now and compare some of the stats from that first time, the second time, and the third time, and look for what kind of differences and things that we can see. Let's do that right now.
All right, so we're going to do a few comparisons from those 3 seasons that the Canucks did go to the Stanley Cup Finals. This page that I'm on right now is the Canucks page on NHL.com. You can get all kinds of stats there. I'm on all-time stats right now. We're going to look at playoffs instead of regular season. Being a goalie myself, I'm going to choose to focus in on the goalies here because we're not going to have time to do all kinds of different things. And we're going to start by looking at the most recent time that they went to the Stanley Cup Finals, 2011, when they played the Boston Bruins. Now, if you look at that, there's 2 goalies that they used there, as you may well know. You can look at a lot of different things there to compare in a second, but first we're going to flip back to the time before that, when they did play at the Pacific Coliseum, and that you may or may not know the goalie that they had then. Goalie in 1994, when they went to the Stanley Cup Finals, was Kirk McLean, or Captain Kirk as his nickname was. All the same stats exist for him that we can compare. And then we're going to look back, way back to 1982 and see what we have there. The goalie that they had that season was Richard Brodeur. Now, I was surprised actually that there's a lot of stats missing here for this playoff season and playoff seasons before that. I'm not sure why, whether it's just that they haven't published those on the NHL's website, or somehow they didn't keep the stats. I can't imagine they didn't keep the stats for that, for some of these things, but nonetheless, we can still do a few comparisons. Now, it's hard to see this because, number one, it's pretty small, and it's hard to keep flipping back and forth there. So I've got some screenshots here that we can use to compare. There's all of them, right? So we have our 3 different goalies here. We have 4 different goalies, but we're not really going to include Corey Schneider because he wasn't really the starter and didn't play in all of the games. So we're going to compare those 3 goalies and see what we can see. First thing we're going to compare about those 3 goalies is a pretty basic stat that you could call it a goalie stat or you could call it a team stat, but we're going to talk about their winning percentage. Listed for each of them here is the number of games they played in and the number of wins they had. This year, the Canucks, in 2011 here, the Canucks had played 25 games in the playoffs. Now, you might be wondering here why that says 25 and that says 5. These 5 games are part of those 25, right? Those 5 games are part of those 25, where Corey Schneider came in to replace Luongo partway through the game, or Corey Schneider started one game, and then Luongo came in to replace him. So we're just going to focus on these here, all right? And then we can focus on the same thing for the other 2. Now, you might notice that for these 2 guys, they have the same number of wins there, and that's not a coincidence that that is 15. If you get to Game 7 of the Stanley Cup Finals, which they did in both of these years, you will have 15 wins or 16 wins, depending on whether you lose or win that game. In both of those times, they lost Game 7. But to get there, they had to, there's 4 rounds, and they had to win 4 games to win the first 3 rounds, and they had to win 3 games to get to the 7th game, but then they lost that. So that's where that 15 comes from. And you might wonder why that one is so much lower. A couple of reasons for that. In that year, they didn't get to Game 7. They got swept in the final round. They didn't have any wins in the final round. Right? They had 0 wins in that final round. And the first round, another reason is the first round was only a best-of-5 series, so you only needed 3 wins to win that round. So there's where your 11 comes from. Now, does that mean that he's a worse goalie? He didn't have as many wins? No, if we really want to compare this, what we need to do is use percentages. So we're going to use percentages with each of those. And we're going to start with Roberto Luongo and his... Let's put Roberto Luongo here. We're going to start with his winning percentage. He had 15 wins out of 25. Now I'm actually going to put this in the middle here because we want to... So this is a fraction here. This is writing this thing as a fraction. We're also going to write it as a decimal. And we're going to write it as a percent. Right? 3 different ways to represent a quantity. That's not a whole number quantity. Now, if we want to turn this into a percent or a decimal, actually, if we're going to turn this into a percent, this number actually works well to do that. And you can do that without a calculator if the numbers happen to work well. This number works well because that's a pretty easy fraction to change into 1 out of 100. Now, percent, of course, means per 100. So if we're going to make this fraction, one way of changing a fraction into a percent is to make it a fraction out of 100. Now, to do that, I have to multiply this by 4. So I have to multiply that by 4. And if I do that, I get 60. So what that means is that's 60%. If I want to make it a decimal, there's a couple different ways I could do that. For this one, it's simple enough. I am going to do it by just understanding what this means. 60/100ths written as a decimal is 60 like that, right? Because this is tenths, hundredths. I got 60 hundredths, so I write it like that, or 0.6. All right, now if we want to compare the other 2 goalies from earlier, Kirk McLean, let's put that. He had 15 wins, but that's only out of 24 games. All right. Now this number is pretty hard to figure out how to make it something out of 100. You can if you want, but in that situation, you'd have to start running for your calculator anyways, most likely. So probably the better thing to do is think about the other way you can turn a fraction into a percent or a decimal. And this one, I'm actually going to go to a decimal first and then make it a percent. What you can do is recognize that this line right here as a fraction actually means divide, right? So when you say 15 out of 24, what you can equivalently say is 15 divided by 24. So on your calculator, get your calculator out here, if we do 15 divided by 24, that's going to give us 0.625. All right, that's what it is as a decimal. You want to change a fraction to a decimal, just divide it on your calculator, 0.625. So I'm going to write that over here, 0.625. I'll take away that equal sign. Now, if you want to change that into a percent, this one's the easiest way is to work from the decimal, because if you notice over here, when you had 0.60, it's 60%. Those first 2 digits of a decimal are the hundredths, and percent is per 100. So those first 2 digits are going to be the whole number part of the percent. This number is going to be, if you looked at it as hundredths, it's 62.5 out of 100. If you had to write that, you could make it 62.5 out of 100. Now that's not a normal way to write a fraction, so we're not usually going to write that, although you could. But you can write it as a percent, 62.5. You can have fractional parts of percent, as I'm sure you know. Shortcut that people use is they look where the decimal is now. It's right there. And they just bump it over to the right if you're going decimal to percent. Or if you're going back the other way, move it 2 to the left. Right? If you're going that way. So it's pretty easy to switch between percents and decimals. You could multiply it by 100, which is the equivalent of moving the decimal 2 spots. Or you can divide by 100, which is the equivalent of moving the decimal 2 spots the other way. All right. Now let's look at the last one here. Richard Brodeur. Richard Brodeur's stats here. These numbers are not going to work out so nicely, but That's probably worth looking at here. He had 11 wins out of 17. Again, does that mean he's not as good of a goalie because he only had 11 wins? Well, he only played in 17 games. There were fewer games. So fewer wins and fewer games. Already we have between Roberto Luongo and Kirk McLean. Kirk McLean had a slightly higher winning percentage. But we'll have to see for this one. For this one, again, there's not an easy way without a calculator to make that 17 into 100. So what I'm going to do is go back and divide it here. 11 divided by 17 gives me that. Now, that's obviously not a nice terminating decimal. I'm going to just round it to the first three here, 64.7%. Right? The first two spots in your decimal, even if it goes on like that, the first two spots are the whole number part of the percent, and the rest of it is the fractional part of the percent. So if it says 0.6470 ... this part is the whole number part of the percent. Those first two digits there. This is going to be 64.7% roughly if we round it to this. All right, so that's switching between fractions, decimals, percents, and we're also looking at, while we were doing that, looking at winning percentage. Now, of those three, what do you know? Richard Brodeur has the highest winning percentage of those three. Not that they're that much different, but that's something worth noticing. Now, another thing I want to compare here while we have these stats up, there's a couple different ways you can track how well a goalie's playing. One of the best ones is save percentage. Now, it's called save percentage. It's always kind of puzzled me as to why it's called save percentage, but then it's written as a decimal underneath here. Right? Those things are written as decimals. And then, as I mentioned earlier, save percentage here isn't even, they didn't even record it, or at least they don't have it on their site. And looking around on the internet, couldn't find it anywhere. So we'll just compare the other two and leave it at that for today. So let's move that. Let's move Richard Brodeur off of there for now. Save percentage. Now, save percentage actually comes from two of the other numbers on here. The numbers that it comes from, what it's a measure of is, it's a measure of how many saves a goalie makes, how many shots he stops, compared to how many shots in total. SA is shots against. So for Roberto Luongo, he had 650 shots. No, he had 650 saves, and he had 711 shots in total. All right. Now for this one, I'm actually gonna bring Corey Schneider into it here, because even though he didn't play in that many games, we can compare those numbers. The only reason I want to do that is because those are so incredibly close, 0.914 and 0.915. I want you to see where these numbers come from here. So even though he only made 75 saves, he only had 82 shots. Right. So Corey Schneider here, 75 out of 82. Changing those to percents and decimals, we'll do that really quickly here. 650 divided by 711. And we'll do the other one here. 75 divided by 82. All right, now these are actually even closer than it shows on the stat sheet there, because this one is 0.9142 and this one's 0.9146. Just because of the way it rounds, this one would round down to 914, and this one would round up to 915. But they're actually closer than that if we write them down to 4 digits. We have 0.9142 and we had 0.9146. Or again, as I said, that those first two digits, those are the whole number part of the percent, and the rest is the fractional part. So this is 91.42% and this is 91.46%. All right, so they're incredibly close there. It's kind of strange actually, that it works out like that, even though one played so much more than the other. Now, if you did the similar thing here for Kirk McLean, if you took his 761 saves that he made out of 820 shots, he had a lot of shots there. Think about what's happening here. There was 820 shots against, and he played one less game than Roberto Luongo. He had more than 100 more shots in one less game. There were some high shooting games in that season, that playoff season. If you did that, you'd find that you'd get 0.928. So his save percentage 92.8, is higher than either of the other guys there. Well, as much as I could sit here and talk about goaltending and goaltending statistics all day, we better say that that's it because the video is already getting pretty long. But before we do, there is one more thing I want to point out that is something that's an obvious statistic to compare for goaltenders, but one that we're not going to look at, and I want you to understand why we're not going to look at it. What we're focusing on now is using percentages, and the one statistic that probably the first one quoted for goaltenders is this one, goals against average. Goals against average is a different kind of comparison to the ones that we've done. Think about the ones that we've done here. We've done two of them. First we did winning percentage, which was number of wins compared to number of games. That's comparing two things that are the same units. Games won to games played. Games to games. It's a ratio. Same thing with save percentage. Save percentage is shots saved to total shots. It's a ratio. Shots to shots. Goals against average is a different kind of comparison. You do get it from some of the numbers here, but it's a rate, not a ratio. And rates you don't usually write as percentages. That 2.29 there, if you took 59 goals against, that's what this is, goals scored against, and that happened in 24 games. Goals against average is number of goals scored against the goalie, number of games. In reality, it's a little bit more complicated than the way they calculate it, so this number might not match the other two numbers because they take into account the actual time that you were on the ice, not just number of games played. But if you divide 59 divided by 24, you'd get something pretty close to that. 2.29 goals per game. 2.29 goals per game. Since the units are different, it's a rate, right? And you don't express rates as percentages. You could, but you'd lose the units, right? Percentages when you're comparing things that have the same units here. This doesn't make any sense, right? So you can write it as a fraction or as a decimal, but it doesn't make sense to write as a percent, right? Percentages, ratios that have the same units, all right? And that's just about it, all we have time to talk about here, other than maybe to point out that hopefully at some point I'll be doing an update to this video and we'll have some other goalie up here, and that goalie will have 16 wins, which would mean they would have won the Stanley Cup. But until that happens, we can just wait and hope.